Sound design.
All right, when you're doing a crossover alignment, which channel should you start with? Do you start at the top end of the spectrum, the bottom end of the spectrum? So I asked this question to the students of my Audio Analyzer Fundamentals for DIY Speaker Builders course, and they all said the low end, which totally surprised me because I always think that you should always start with the high end. So I don't have an answer to this question, but I am going to talk about it for a few minutes here just to say some things for a couple of circumstances that I hope will help you also think about this for doing these kinds of alignments. So the two main things I can think of are, number one, which audio analyzer you're using. I think that will influence your workflow. And number two, just logistically, what order does it make sense in so that you can just sort of keep adding delay and not have to go back and update every channel that you already worked on. So let's talk about this first circumstance. Imagine that you're doing a main sub-alignment in the field and you're using a real-time audio analyzer. In that case, almost every time that I can think of, you would want to start with a full range driver for two main reasons. Number one, that's what we need to set our delay locator. Merlin Van Veen has created a great comprehensive video about why this is important and most likely the case every time, and I'll just link to that in the show notes so I don't have to go through it. So real-time audio analyzers, we need a full range signal with high frequency content to set a delay locator. It's typically more difficult and a little bit more squirrely with band limited signals, especially subwoofers. Number two, this is often the situation we're working with. We have created a problem here by moving our main away from our sub. They become uncoupled. And now the main is farther away from our audience. So imagine that maybe we have an audience over here and our main is significantly farther away. So just logically, it makes sense that we'll need to delay our sub back this way so that they arrive at the same time. Not knowing anything about the phase compatibility of these two models of speakers, we just know looking at this setup, we're going to end up probably adding delay to this guy. So for those two reasons, you're almost always starting with the full range driver, the full range speaker when you are doing a crossover alignment in the field with a real-time audio analyzer. So let's talk about a second case. Imagine that you are doing the alignment for these three drive lines. So you have a mid and a high combination here, a low mid, and a subwoofer. These are all from EAW speakers that I measured in the field, and I'm actually working on doing alignments for those. So where should I start? Should I start down here or should I start up here? Well, I initially just started up in the top because that's what I'm used to. But I ended up adding delay and then coming back to this channel because of some stuff that was happening. What I realized is that I should have started by looking at all of the phase responses to see which is the one that's arriving latest. Everything else is going to need to get delayed to that. I want to switch over to looking at the phase graph, but before I do, I'll put in these markers so we can just remember where our acoustic crossover regions are, marking the center here of each of them. So now we're looking at the phase graph here, and I know this is a lot of information, but if we just, calmly try to take a look at this stuff, I think if we want to figure this out kind of quickly, it can help to just try and look at it all together. So I'm going to start moving the time zero reference here so we can try and get everything kind of on the page at once. Now it would be nice, this green guy seems like a bit of an outlier. So I'm going to go over here and hit a polarity inversion so we can have everything now kind of on the same page. And just quickly looking at this, what I'm seeing is that it seems to me that the red guy is the steepest guy. Let me find a good color here. So it seems that the red is steeper, so green is going to have to come down in this direction to meet the red guy. we can see this green guy here is going to have to become more steep to be like the red guy. And same thing with this blue guy. It seems like this blue guy will need to come down to meet the green guy if we look at this line here. Now, if we move this reference so that we can see these all a little bit better, like that. Now, ignore this red guy for a second. This is really hard to tell, right? So for me, red and blue, high frequency and low mid, I could go either way with those. But if we're already thinking we're probably going to need to either delay the low mid driver, this green guy, or create some, phase shift in this negative direction, then we'll probably need to do the same thing to the high frequency driver to keep up with everybody else, or to slow down to everybody else, I guess is a better way to say it. So I hope this isn't too confusing looking at these all at once, but for me, if we're trying to make this simple choice of which one to start with, I think it's not too bad to look at these all at once, try to get them all on the same page, and then say, okay, which one's steepest? It's the red guy, then the green guy, then the blue guy. So that's the order that we'll do them in. We'll start in the low end. Just in the end here, I'll throw in one quick idea, which I don't know if will help you or not, but it could be interesting to look at a filtered version of these also for just making some gross decisions. So let's zoom in here on the impulse response. Let's go to 100 milliseconds. Let's go closer. Let's go 50 milliseconds. Now let's put a peak filter on all of them at this first point. Okay, 86 hertz. And now if we ignore the blue guy and just look at the green and red guy, it's looking like, and let's make them, let's give some more space here. It's looking like this green guy might need to go back this way if it wants to be more like the red guy. Okay, so this is confirming this idea we had that we may need to delay or just create some phase shift of our low mid driver to go back and be aligned with the sub. And we can do the same thing at the other frequency, 342. And now, if we ignore the red guy, let's just mute it. And we can even zoom in more, 10 milliseconds. And we see, a similar story with this blue guy. It's looking like it's going to need to go back this way if it wants to look more like the green guy. So again, confirming this idea we had that we're going to need to delay the high frequency driver back to the low mid driver. Okay, so those are all my suggestions for you. Which channel do you start with? If you're doing, real-time audio analyzer in the field, you're almost always going to start with the high frequency driver, the full range driver to set that delay locator. And then if you are, doing some speaker design here and you're working with non-real-time measurements and you have time to go through this, then you may want to just take a quick State of the Union observation of all of the phase traces and see which one is the most steep, and then everybody else is going to have to become more steep to match. So I hope that's helpful. I'd love to know your thoughts on which channel to start with. So please comment on this video, and thanks for watching.
Sound design.